Welcome folks. So we decided to give tutorial videos for each weekly lab in the electrical engineering circuit labs here at Washington State University, where students can watch those labs and prepare them before they come to the lab. So when they come to the lab, they can basically hit the ground running as soon as they come in to the lab, and this way they can save more time for studying later on. So I decided to make those videos, and I want to share them on YouTube, so any of you who are interested in watching those videos to gain from them, they are welcome to do so. So the first lab we give is basically deals with electric quantities and their measurements. So there are 4 major quantities that we're going to deal with in this lab, and we need to learn how to measure those quantities. So here is the lab objectives. So students need to learn the basic definitions of voltage, current, resistance, and power. The students need to learn how to use the DMM, Digital Multimeter, to measure the voltage according to the voltage polarities. Students also need to learn how to use the DMM to measure the current according to the current's direction, Students need to learn how to read the 4 bands resistor code and how to measure resistance using the DMM. Students need to connect elements in series and or in parallel using the breadboard. Students need to learn how to calculate power using measured voltage, current, and resistance. And the students need to be able to validate the conservation of power law. So let's look at the first experiment. The first experiment is very basic. Basically, we're going to deal with voltage and current measurements. So you need to build this circuit in the lab. So the circuit basically will have a voltage source, which is a power supply. This power supply is supplying electric power to a resistor. So it's a very simple circuit. We need to connect this circuit on the prototype board that we call a breadboard. The breadboard is basically a prototype board that is used for testing and prototyping. So we need to build this circuit using the prototype board. Now basically the voltage as a definition is basically defined as the amount of energy required or delivered to move 1 coulomb across the element. We know that according to the conservation of energy law, the energy can't be destroyed nor created. We can't create energy from nothing, nor we can destroy it or annihilate it, but it gets converted from one form to another one. So if we're dealing with electric circuits, we are interested in the electric energy. So the electric energy is created by separating charges, especially opposite charges. If you separate opposite charges, they need to come back together. So the electric energy is basically the energy required to separate opposite charges, right? And then and if you were able to do that, then basically you have electric energy. Now if you let the charges go, they're gonna come back together, so that energy need to be dissipated. So it's the form of electric energy is basically potential energy, is the potential due to the separation of charge. So if you think of the power supply here as a battery, for example, then the battery will be able to separate those electric charges, the 1 coulomb charge. Right? And by separating the 1 coulomb charge across the element, then there were electric energy created because we have separated the charges. So the voltage across this element here is basically means that if we have a 1 coulomb, we will have V joules exerted to convert it to electric energy. So the battery here is basically creating an electric energy. Now, those charges need to come back and combine together, so the way we're going to be able to combine them is to send it through this element. So this element basically will allow the charges to come back and combine again over here at the other side of the battery. And by doing that, this element, which is the resistor, will absorb that electric energy. It converts it to heat or heat and light. So the basic idea is that the voltage is the amount of energy required to separate 1 coulomb charge across the element. So 1 volt means that if I have 1 coulomb going through here, then this battery exerted 1 joule to separate this 1 coulomb. Now the current basically says that the rate of charges flowing through the element in 1 second. So how many coulombs will flow through the element in 1 second? So this is the definition of the current. The resistance is basically the tendency to resist the current to flow. So if there is current flowing through this resistor, there will be a voltage across it, because it will experience that resistance by converting that electric energy into heat. The power is basically the rate of change of the energy, how many joules is delivered, exerted, or absorbed, converted to heat and light in 1 second. So it's basically the derivative of the energy, the rate of change of the energy with respect to time. That's what the power is. So in any circuit, if you sum the amount of power supplied by each element in the circuit, should equal to the sum of the power absorbed by each element in the circuit. So basically it's the conservation of power, which is the derivative form of the conservation of energy. In any case, you need to build the circuit using the breadboard, and then you need to learn how to measure the voltage and the current using the DMM. So to measure the voltage and the current using the DMM, this DMM1 will be used to measure the voltage across the power supply. So the way you want to do it is you want it to configure the DMM to measure voltage, and you measure the voltage across the element. So the plus polarity in the DMM should be the same as the plus polarity of the voltage. You see the voltage here is at the top, so the plus polarity of the voltage should be connected to the plus polarity of the DMM, and the negative polarity of the voltage should be connected to the negative polarity of the DMM. So the DMM need to be connected across an element to measure the voltage. However, to measure the current, you need to know how much current going through this resistor, for example. So you need the DMM to sense this current. So this current needs to go into the DMM and then come back to the resistor. So that's the way we need to measure the current. When you measure the current, the DMM need to be connected in series with the resistor. So the way we do that is we break the resistor from the top. So if this is your resistor, break it from the top and then connect the DMM between the circuit and the resistor. So if we break the resistor from the top here, then I'm going to connect the DMM to measure the current from the top node, which is from the power supply to the resistor. This way, the current that comes from the power supply goes through the DMM and comes back into the resistor. So the DMM is connected in series with the resistor. Now you need to make sure that the arrow of the current will enter the plus polarity of the DMM. The plus polarity of the DMM, when you measure the current, it becomes ammeter. So the power is basically going to be the voltage times the current. P as a power will equal to V times I, whatever you measured voltage times whatever you measured current. So in the second video, when we're gonna build the circuit to show you how to connect the circuit and the resistors and the voltage and the current, then we need to learn how to configure the DMM to measure voltage and how to configure the DMM to measure current. So in this experiment, we're going to measure the voltage and the current at the same time, and you will be able to measure the power. So I will show you how to hook it up in the lab in the second video. So this is the first experiment that you're going to do. So in the second experiment, we're going to basically validate the conservation of power law. And the idea here is that how to determine if the element is absorbing power or delivering power. So I have a very simple rule. Basically, you look at the arrow of the current and the plus polarity of the voltage. If the arrow of the current enters the plus polarity of the voltage, if the product is positive, the element absorbs power. Else, if the product is negative, the element delivers electric power. Here we deal with electric power, right? So if the element absorbs electric power, we call it passive element. If the element delivers electric power, we call it active element. Now, most textbooks, including our textbook, the one that we use here by Nelson, that they have a convention. Usually power is a scalar quantity, so is energy. But you need to know if the power is absorbing or delivering. So the convention in the book, it says that if the power is delivering, it's a negative power. If the power is absorbing, it's a positive power. You know, this is just a convention that the textbook has. But in general, power is a scalar quantity, so is energy. But we need to know which form we are in. Are we converting that chemical energy in the battery into electric energy? Are we delivering electric energy? Or are we absorbing that electric energy and converting it into light and heat or mechanical energy? So this is basically a convention, and basically we say that if the element absorbs power, it's going to be a positive power. If the element is delivering power, it's going to be a negative power. It's a convention. It's basically the way we deal with it in our textbook. However, if the arrow of the current enters the minus polarity of the voltage, if the product is positive, then it is delivering power, else the element is absorbing power. Those are the two rules I have here. So if we look into this circuit, that's in the second experiment, we're going to have a voltage source, we're going to have one resistor here, another resistor here. So you can see that this current here leaves the plus polarity. That means it enters the negative polarity because the current will go through the element. So if the current enters the plus polarity, you multiply this voltage times this current. If the value is positive, this is basically supplying or delivering power. However, over here, the resistor, and resistors always absorb power, by the way. So if the current enters the plus polarity, and if the product V times I is positive value, then this element going to be absorbing power. The same here, that this current enters the plus polarity. So if the current enters the plus polarity and the product I times V is positive, then this element is basically absorbing power. So in this experiment, what we want to do is we wanted to measure the voltage, and the voltage here is going to be the same. We can test it in this experiment. In the next lab, you will know that by KVL, that those voltages are going to be the same. By Kirchhoff voltage law, those voltages are going to be the same. But we're going to measure I, which is the total current, I1 that flow through R1, and I2 that goes through R2. So to measure the voltage and the current, what you need to do is remember when you measure the voltage, you measure the voltage across the element. So DMM1 will be used to measure V, and basically we're going to connect this voltage across this element. And to measure the current I need to break this voltage source from the circuit. So by breaking it from the circuit, this portion becomes open, and then you need to connect the DMM between the power supply and the remaining of the circuit. So that's what we did here. We break the power supply from the circuit, and then we send the current to go through the DMM, leaves the DMM into the rest of the circuit. So you break the power supply from the circuit by removing one side of it, the connection of one side of it, and then you place or you connect the DMM between the power supply and the rest of the circuit. This way the current comes from the power supply will go into the DMM. Now you need to keep in mind that the current will enter the plus polarity of the amp meter. This way you get the right reading. If you did the other way, you're going to read the negative value. Right? So you want to make sure that the current enters the plus polarity of the DMM. And this will give you the total current. It's basically the current of the power supply. Then what you want to do is you want to measure I1, and to measure I1 you need to break the circuit from the top. So once you break the circuit from the top here through R1, you want it to connect the DMM in series with it. So this is the way I will do it. I'm measuring the voltage across the element, and then I'm gonna come to the resistor. You see how I broke the resistor from the top? So the resistor from the top here is broken, and then I connect the DMM from the circuit from the top to the resistor, so that the current going through this resistor will go through the DMM, leaves the DMM, and comes into the resistor, and the current must enter the plus polarity. So this way you will measure I1, which is the current through R1, right? And keep in mind that the arrow enters the plus polarity as I just said. Finally, you want it to measure I2, and you do the same. Basically, you're going to break the resistor from the top and replace the DMM in series with it. Can you break the resistor from the bottom? Yes, you can, but it's going to be a little bit cumbersome sometimes, because you're going to have this common node. You need to be careful when you're going to break the resistor from the bottom, how you're going to connect the DMM. It's easier to break it from the top, easier to see. So we're going to break the circuit from the top. When we do that, you break the circuit from the top, so the resistor becomes here. You want it to place the DMM in series with R2. So I2 will flow through the DMM and leaves the DMM into the resistor. So basically the DMM is in series with the resistor. Once you measure this current, I2, then you do the product I2 times V, which is P2, the power absorbed by R2. And then you also measure the power absorbed by R1, which is I1 times V. This should equal to the power delivered by the power supply, which is basically V times I. This is the second experiment that you're going to deal with, and you're going to validate the conservation of power law. Once you do that, then basically you are done. But in order to build the circuit, you need to use the breadboard. So breadboards come with different shapes. So this is one shape of the breadboard that commonly used in our lab, that is provided by the supplier of our kit. I want you to see the way we lay it down. We lay it down in this horizontal fashion or layout. It's basically the landscape layout, right? So that's what we have. And then I want you to see that there is two banks, one bank on the top and another bank on the bottom. Those two banks. Now each of those two banks has columns of 5 holes. So there is 1, 2, 3, 4, 5 holes here, 1, 2, 3, 4, 5 holes here. The next column, and the next column also 5 holes, and you have basically a sequence of 5 columns on the top bank and the bottom bank. And in the middle there is an insulation, there is a separation between the top and the bottom. So that's the first thing I want you to see when you look at the breadboard. The second thing is that each of those 5 holes in any given column, each one of those are internally connected. So those holes are shorted. They are the same. They are basically a single node. Those are nodes. Basically, you can think of it as just a node. Those 5 holes here are a single node, which are different from those 5 holes next to them, which are another node. So each of those adjacent nodes are separated, isolated from one another. so is the top bank and the bottom bank. Those are 5 holes which assemble a node, are separated from the bottom 5 holes. Those 5 holes are isolated from those 5 holes. This node is isolated from this node. So basically what we have is columns of nodes, right, on the top bank and on the bottom bank. They come in different shapes. This breadboard here has the top bank, like we stated, and the bottom bank, like we stated, but also they have power supply rails. So those are power supply rails. This here, the horizontal rail, is a single node. They basically used for power supply. So if you're going to use, for example, a single 10 volts voltage source connected to a bunch of elements, if you have this kind of breadboard, you can use the top rail here for the 10 volts. All those holes here, horizontal holes here, are basically a single node. They are all connected. Some breadboards will be separated across the middle, some are not. But this one here gonna be connected all the way through. So you have 2 rails on the top. Here is another rail. So this is the first one, that's the second one. We call them power supply rails. So you can use 10 volts here, you can use ground here. You have 2 at the bottom here, so you can use, for example, negative 10 volts. You can use plus 5 volts for another one. So here we have 4 power supply rails. Some of you will have this kind of prototype board. Some of you will have this simple one. Some of you will have this type of breadboard. There is another one that some people will use, is basically it has 2 power supply rails. So we still have the top bank, the bottom bank, and then we have those 2 power supply rails. So those holes, the vertical holes, are basically used to connect elements together. So if you have a bunch of elements connected to a single node, you can use those 5 nodes here for 5 holes to be connected together, where you're going to have like 3 resistors and the power supply connected to them, for example. So in the lab, I will show you how we are going to connect the circuits that we have, the simple circuits that we have, into the breadboard. So I will use the first type of breadboard in our demo, and we're going to do that in the next video. Thank you so much, and I hope you enjoyed this video.